Excuse me. All right, everybody, here's 7.2, and 7.2 is multiplying powers with the same base. So the first thing I want to start with right here is this part that I'm zooming in on, vocabulary-wise. Okay, so I'm going to say certain things, base and exponent, and that kind of stuff. I just want to make sure we understand what I'm talking about. So when I have something like here, I have 2 to the third power. Okay, there's a lot of time we have that is how we say it. So the base is the 2, the big number, and of course the 3 is called the exponent, and kind of the whole entire thing is called a power. I know we say to the third power a lot of times, but 2 to the third power, that's the entire thing. 2 is the base, 3 is the exponent. So when I talk about exponents or I talk about bases especially, that we know what I'm talking about. Okay, so here and then hopefully again, by request, the notes, note guide things, I started those back up as well. So if you haven't used the notes guide, or that should be on Canvas if you aren't using it right now. So if you want to go grab that quick, go grab that so you can write this stuff down, because I'm just going to keep rolling otherwise. So here's what we're doing today, or a big part. We're doing a couple of different things, but a big part of it is going to be multiplying numbers with the same base. So 2 multiply numbers with the same base, right here. 2 multiply numbers with the same base. All we are going to do is simply add the exponents, okay? Now, yeah, great. If you can read that, remember that, no problem. You're good at memorizing, then you're going to be able to remember this pretty easily. But I'm also going to show you why that works. So, just like it says up there, to multiply numbers, I have 4 to the second times 4 to the third, to multiply numbers with the same base. They both have a base of 4. All I have to do is simply add the exponents. So this is the same as 4 to the 5th power. Whoa, swing and a miss. So why? Why does that work? I want to make sure I show you that one time why that works. So to show you, or I think the easiest way to show you, is to actually take 4 to the second times 4 to the third and actually write it all the way out. So what does 4 to the second power mean? It means 4 times 4, right? And then times 4 to the third means 4 times 4 times 4. So right there you can see it pretty easily that we have 5 4s, or 4 to the 5th power. Okay, so instead of having to do this every single time, we can just remember that, oh yeah, when I'm multiplying, all I'd really need to do is just add the exponents together, because if you look in the next one, like it's x to the 7th times x to the 8th, I don't want to spend a ton of time writing out all of those x's. That's kind of nuts. So it doesn't matter if your bases are numbers or variables or whatever, as long as your bases are the same, both of these are x, I can just add the exponents to get my answer, okay? Not too hard, right? Okay, and those two, no, not too bad. What makes them harder is one like this. So kind of ratchet up pretty quickly here. So this one, I have 3 things being multiplied together, and I know a lot of times people see these parentheses and think those mean something. The only reason I put parentheses in there, or that you'll see parentheses in a problem, is just to help kind of separate things a little bit, so we know that's a -3 and not a -3, that kind of stuff. Okay, here's where we got to be careful, okay, because here's what happens a lot of times. These 2 numbers right here, actually let me highlight them. This number and this number, this 2 and this -3, those are not exponents, right? Those are just regular numbers. Okay, so a lot of times people get confused or make mistakes because they treat these regular numbers as exponents when they're not. Okay, so the exponents are the y to the second, the 4 on the y, those are exponents, right? So this is all being multiplied together. And remember, way back when you first learned about multiplication, we learned how when we multiply things together, it doesn't matter the order that we multiply them in, right? 2 times 5 is the same as 5 times 2. Okay, that works for that simple problem. It works for this problem too. This is all multiplication. Okay, so what I'm going to do is I'm going to multiply the things together that I can, and then use the exponent rules for the things that I can use for that. So I'm going to take 2 times -3. That's -6. Okay, I can't multiply those by the y's or anything like that. Okay, but now I'm going to take my y values. I have y to the second, y to the 4th, and y to the 8th, and I'm going to add my exponents together. Okay, so 2 plus 4 is 6. 6 plus 8 is 14. And that's it. Okay, so if it's just a regular number, treat it like a regular number. If it's an exponent on a variable or a number, then you can go with your exponent rules from there. Now this exponent rule as well, it's the same thing if the numbers, or if the exponents, excuse me, are positive or negative. So like if I take this problem and if I change this, let's say instead of y to the second, this was y to the negative second instead. Okay, how's that going to change the problem? Well, 2 times negative 3 is still negative 6, so that's not going to change at all. But otherwise, the only other thing I got to do is I'm just adding together with a negative number. Negative 2 plus 4 plus 8. So negative 2 plus 4 is 2, 8 plus 2 is 10, that would be y to the 10th. Okay, so it doesn't matter if they're positive or negative. If they have the same base, we just add them together with whatever they are. Okay, so that's going to be the majority of the assignment, is going to be multiplying numbers with the same base. Okay, hopefully again too, like you can see, you know, coming from systems of equations in chapter 6 to this, a lot less work to do, right? So these problems hopefully should go a little bit quicker as well. Now, this next part, this is a little more tricky, a little more difficult in my opinion. So this next part, we're also going to throw in here some rational exponents. Okay, so when you hear the word rational means a lot of times a rational number could be anything, a decimal, a fraction, something like that, but most likely our exponent is going to be a fraction. And how do we do that? Okay, so this chapter we're on a big exponent kick, right? So we've talked about negative exponents and zero exponents and that kind of stuff, and now we're talking about some of these what I like to call exponent rules, right? So what happens, or how do we find the answer to examples like this? Okay, all right, so here's what this means, and let me kind of, before I get to those examples, let me show you something. We all, hopefully not all of us, but hopefully we remember or know or have seen before square root, right? Like if I want to say or ask you, what is the square root of 36? Okay, that means I'm looking for what number times itself is 36. Square root of 36 would be 6, because 6 times 6 is 36. Okay, so another way we could write that, the square root of 36 is the same thing as 6 to the 1/2 power. Okay? Square root is the same thing as saying the 1/2 power. Okay, so here's how we figure out these. Both of these are probably going to be calculator problems, these examples up here. So when I have 4,096 to the 1/4 power, so just like I said that the square root of 36 is the same thing as the 1/2 power, I'm going to use this same symbol, which a lot of times people say, like if I ask you what I just wrote here, you're going to say that's the square root symbol. Technically, that's not called the square root symbol. That's called a radical symbol. Okay, because we can use that symbol not just for square root, but since this is to the 1/4 power, I am looking for what's called the 4th root of 4,096. Okay, so not the square root, I'm looking for the 4th root. Or in other words, I'm looking for what number times itself 4 times equals 4,096. Now obviously that number, like to try to do that mentally, it would be pretty tough. Just to grab your calculator and start guessing and checking, you know, eventually you would get there, but I'm going to try to show you. So I'm going to flip over to my camera here, and bear with me, this is going to be kind of difficult to hold this. So, all right, here's my calculator that I have. Let me try to move it so it's not a glare as much. There we go. Here's my calculator. So if I want to do the 4th root of 4,096, here's what I do. My first thing, well, I turn it on. My first thing I'm going to type in is my 4 for the 4th root. Okay, and then over here at the left, kind of next to the 7, are the buttons that we would use for exponents and for roots. So if I want to do the 4th root, I'm going to press the 2nd key, and then I'm going to press this little like arrow up caret button. And so you see how it has that little X next to that radical symbol? The 4 in front of it, the 4 that we type in first, tells the calculator, sorry, hold on, there we go, sorry. The 4 in front of it, there we go, tells the calculator that the 4 goes in for the X, so this would be the 4th root. Now I just type in my number of 4,096, and that equals 8. So in other words, we're saying that, or this means that 8 times 8 times 8 times 8 is 4,096. Okay? All right, let me go back to my document. Okay, so the answer to this would be 8. Okay, and if you are watching this video and you need help with that, there's only going to be a couple problems in the assignment like that, so if you can't get them and you're not sure how to do them on your calculator, Don't worry about it. Just make sure, like, the next time you see me in school, or if we can Zoom or something, then I can show you a little bit more carefully. Maybe you have a different calculator than mine or something like that, okay? All right, so the next one, a little bit different still, a little more difficult. This is 125 to the 4/3 power. Now, to do this, to leave it as 4/3, that is really weird and difficult. So here's what we do, okay? We change this, or I guess what I should say, we expand this. We're going to expand this number a little bit so that we can work with it a little bit easier and use our calculator to help us out. Here's how these always go. This number right here is the exponent. This number down here is the root, just like this one, right? It was 1/4, so it's the 4th root. The 1 on that one is the exponent, but I don't really need to use it because it was a 1. So here's what this means. I'm going to rewrite this. I can rewrite this as 125 to the 1/3 power, and then I just got to take all that times the 4, or to the 4th power. Okay, so all I do to do this, to work through this, again, I take the denominator and I leave that there by itself, and I'm going to do the root of that. So this means I'm going to do the 3rd root of 125 with my calculator, just like I did the 4th root of 4,096, and then whatever I get for my answer, I'm going to take that to the 4th power. Okay? So let's try this again. So if I, again, grab my calculator, type in 3, the second key, use that little arrow button to get that radical symbol with the x in the corner, and then 125, that gives me 5. So let me go down here. So that means I have 5, and then to the 4th power, so 5 to the 4th power would be 625, would be my answer there. Okay, so there's only a couple examples of those in the assignment, excuse me, just like this. So these two, again, are the same. Remember, this one is the same thing, where that this is the exponent, this is the root. So we took the 4th root of 4,096 and got 8, but then I don't need to worry about 8 to the 1st power, right? Because that's still 8, so we just don't need to worry about it. So if that top number is 1, we don't have to worry about it, okay? Because it's not going to change our answer. If the top number is something else besides the 1, like this one, like a 4, then we still use the denominator. We find the root, like this one was the 3rd root, and then whatever that numerator is, that's what we're going to use for the exponent then in the end, okay? So if you have trouble with that, especially with calculator stuff, please let me know, and I can help you get that figured out, because you're going to want to use a calculator for those. All right, good luck.